Welcome now for the second talk of the evening, Andrew Miller. Hello. Okay, could we get on with the meeting, please? Okay, so now for the second half of the meeting, we're delighted on a completely different topic. We're delighted to welcome Andrew Miller, and he's going to talk on some research he's done with price forecasting using Python and Bayesian regression. Let's have a warm welcome for Andrew Miller.
Thank you. So my name is Andrew Miller. I'm going to talk a little bit about Bitcoin price variation forecasting. This is something that I learned in grad school, which I recently graduated from NC State with my master's in computer science. I don't trade, so and I don't know a lot about Bitcoin, but I learned something doing a project in a course called Algorithms for Data-Guided Business Intelligence, and that's what I was going to share with you today. Just a little bit about my background. So I did work in finance, I'm a software engineer by trade. So I worked at Fidelity Investments, and I helped them to develop a tool called Mutual Funds Evaluator. I did a lot of front-end work for them. I also worked at Deutsche Bank and helped them develop the tool called Equity Pricing, and it's an internal tool. And then I worked at Watson Health on a project called Flexible Analytics, and the part that I did was dealing with patient financial data analysis. And the slides have links in them, so you can check those things out if you're interested. And presently, I'm with IQVIA. I am a data science developer, IT architect, and I work on a project that deals with disease detection using EMR data, so electronic medical records. So this project that I did in this course in grad school, it was based on a paper titled Bayesian Regression and Bitcoin by Devavrat Shah and Zheng. And you can kind of see the links here. They're from MIT, and this paper was published in 2014. So it's somewhat old, but I think there's still some value in it. I hope that you will learn something from this. So the paper used one data set, and then the project that I did used a different data set. In this paper, the authors, they used data from okcoin.com, and the data was the prices, the Bitcoin prices that they used were in yuans, and they were looking at data between February 2014 to July 2014, and they analyzed over 200 million data points. And then the project that I did for this course, they kind of provided us with data from bitcoincharts.com, and that data was in dollars. And it only had like a few days of January 2014, basically 24,000 data points. So not a lot, but it's more of an academic for learning purpose is what the project was. And so this paper talks about forecasting Bitcoin price variation. So it's not actually forecasting the price itself, it's forecasting how the price is going to change. And so in the introduction, they're talking about different ways that people have done this kind of forecasting. One of the ways is using technical analysis, basically looking at different patterns like head and shoulders or triangle patterns, and not noticing those patterns in the data and then acting on them. And then they were kind of evaluating some of the problems with those techniques, which are one of the issues is it's subjective. So somebody has to sit down and identify the patterns. And the other problem is also manual. So what they propose to use is an approach called Latent Source Model. And it's basically an automated way of doing technical analysis, the way I understood at least, reading the paper. But it tries to model price variation patterns, but instead of somebody sitting down and kind of putting together those patterns, the computer identifies those patterns and it learns them too. So then the subjective sort of part is excluded from the process. So part of this project was data prep, or at least part of the paper rather. And for the project, I didn't actually need to do any data prep. We were already provided with a data set that was somewhat cleaned up and imputed and clustered and all that. But the paper talks about basically splitting the price changes into intervals, 30-minute interval, 60-minute interval, 120-minute interval. And then each of those intervals, they would basically record a price change every 10 seconds. And at the end of every 10-second interval, they would also record the final price. And then they would average across all of those final prices, and then they would use that as a label in their training algorithm. And then they would use the other intervals as their sort of input. So one of the things that they did to be able to actually run this problem, to solve this problem, because they had 200 million data points. There's a lot of data, and they only had access to a small, relatively small computer. So they had to try to reduce the search space a little bit. And they used an algorithm called k-means clustering. And so out of those 200 million data points, they basically found 100 clusters, and then they chose only the 20 most effective clusters. In the paper, I didn't see anything actually saying how they identified what effective meant. So not sure how they did that, but in the project, it was done for us, so I didn't have to think too much about that. And then they took a representative pattern from each cluster. And so in this picture here, you see kind of how the k-means clustering algorithm works. You basically start off with a bunch of points, and you see them blue and red crosses, and they're basically cluster centers, and then the algorithm tries to move those cluster centers to where they're actually supposed to be, and at the end you see that the blue cross kind of ended up in this cluster, and the red cross ended up in the cluster on the bottom left.
What are the axes?
Good question. In this particular example, obviously there's no labels. So for this particular problem, let me think about this a little bit. So whatever, my understanding is the distance. So you'd have to have X and Y coordinates, and then the algorithm identifies sort of the closeness based on Euclidean distance. So I would think that X and Y would be some measure of basically how a pattern is different from each other. So that, as I said, like they didn't provide what it meant to be effective clusters. So that part I can't answer. But so if you think about this in an abstract way, this is what happens: is they find sort of a point in that cluster that is very similar to the rest of the points, and then they take sort of the points around it that are representative. And from what I understood, again, the representative part, they kind of handcrafted. And they didn't discuss that in the paper of how exactly they did that. So it's hard. I could only like speculate of what exactly they did. So, but as a result of this clustering algorithm, they ended up with a much smaller data set. And so they didn't need to run the entire 200 million data points. They only needed to run a smaller subset. And so they discussed actually some of the representative patterns that they identified. And so they saw the head and shoulders and triangle patterns in those clusters, and where they said pretty much latent source model does what technical analysis does, but with it's automated, so to speak. So, and then the next thing that they were talking about is training the model to actually be able to predict the price variation. And so that's where Bayesian inference came in to be able to estimate average price change. And then they use linear regression to build a model that can actually predict based on previous data. So, and this is just a quote straight from the paper. Why they use Bayesian regression is because it allowed them to utilize those patterns that you just saw without explicitly finding them, so that the machine kind of did the work. And for myself, I can also say that one advantage of Bayesian regression or inference is that you could improve your estimates as you receive more data. They didn't really take advantage of that particular feature, but I think this could be useful if you wanted to do sort of online training, or basically as more data comes in, you improve your model. And for people who are not familiar with Bayes' theorem, this is kind of the basis of Bayesian regression or Bayesian inference. This is kind of the equation of how or why it's possible. I'm not gonna read all of this to you, but I really like this quote. Bayesian is one who, vaguely expecting a horse and catching a glimpse of a donkey, strongly believes he has seen a mule. This really, it's, I guess the gist of this equation is that you can use prior knowledge to estimate or get probability of future events, and so that's where the sort of the prediction forecasting aspect comes in. And some of the examples of using this in, for example, trying to identify disease based on symptoms. So what this means is there is a probability of getting a specific disease given a specific set of symptoms. And this is how you compute that probability. Basically, this product divided by prior knowledge. And well, prior knowledge is also here on the top in the numerator. But the idea of this is that you can adjust your vision of the world as you receive more data. So, and that's what they take advantage of in this paper. And they go into some complicated math to derive this equation here, called conditional expectation or conditional mean. And this is basically the average price change estimation. And it's based on that equation that I was just showing earlier, the Bayes theorem, but they had to do some manipulations and estimations to come up with this equation. And subscript AMP just means that it's based on empirical data. They actually used historical data to approximate the conditional distribution of price changes, because they don't know the real distribution. I don't think anyone knows that. So, and so this is sort of an approximation. This is not exact, obviously. And then they apply linear regression to this average price changes. So in here in the paper on the left, the delta P, they are basically average price change within a specific time interval. So they use 3 time intervals, right? The 30-minute, I think 60-minute, and 120-minute. And so that's why you see from 1 to 3. And then they use this R. I actually don't know what that is. I didn't make, couldn't make sense of it. And in the project, we were not asked to use that either. It was kind of a dumbed down version of it, which is just take the change, the past change within the 90-minute interval, or sorry, this is actually the 30-minute interval, the 60-minute interval, and the 90-minute interval. And then based on that, you can come up with an estimate for what the price is going to be in the next 10-second interval. And this really, the way I look at this is almost like it learns to recognize a pattern, a specific pattern, and then gives you sort of the future average or expected value based on that pattern. And they didn't discuss this, but I think they could also improve this and like break it up into more granular intervals, not just like every 30 minutes, but every 15 or 5. They didn't talk about that all that much. So, and then I have a demo that I want to show, pretty much the code that I wrote for this project. So I'm going to drop in, and hopefully this will be interesting for more like technical folks. And part of this code is actually boilerplate that was given to me, and I had to fill in the gaps.
Did you possibly make the font like about 8 times
yes,
larger
yes,
than that?
I'm going.
Because you've got
Yeah.
people in the room.
Yep. Just give me a second. I know there is presentation mode.
Probably just do Control A and then set the font or something. I don't know.
It doesn't work that way, but just give me a second. It should be here somewhere. I keep on missing it.
Which editor is that, by the way?
This is PyCharm. Trying to find it. This is the community version though, and it may not be available in this community version. So what I could do is open it in a different editor so you guys can see where I can change the font size.
Much better, much
Yep.
better.
Okay. So here you can see a lot of lines of code that are loading CSV files, and I will actually show the data. So the original data set that was used in the project is this, and it's a time in epoch. So it's number of milliseconds, I believe, milliseconds since like 1970. Yeah, thank you. You could use a converter to get to convert it to normal sort of.
Could you zoom that into,
yes. Yep. Just give me a second. And so the other column is the price at that time. And so this is sort of point prices. So professor converted all of that for us and clustered it as discussed in paper to a file that looks like this.
could you zoom that?
Yeah. Yep. So you can see every column here is a price difference. And this price difference is computed over a 10-second interval. And then
What's difference from what exactly?
Basically, start and end. The difference between start and end. Yeah. And then on the very right, so you can see there's 90 of them because 30 minutes. And then the project actually used a 20-second interval, not the 10-second interval discussed in paper. So that's why you see 90 intervals. And then they have this YI, which is the label, which is the average of the intervals following each of these price difference intervals. And there's roughly 50 patterns like that. So every row is sort of a pattern that then is used by the algorithm to learn to predict the price variations. And the rest of the files are very similar. There is, I'm sorry, you cannot probably see, but there is test and train files, and then there is two sets of train files. One that's basically prior knowledge, and the other one is new knowledge. And this allows them to use Bayesian regression or Bayesian inference. They use the second file to improve the original sort of distribution estimation. And so here in this code, you can see basically it says read CSV, so it's loading all of the data from CSV file. And then down here is defining a function called compute delta. But what this really is, just jumping back to the presentation, is this average price change estimation. So that function just computes this equation.
So just so I understand, so you're saying historically, whenever we had this bunch of changes for the preceding 90 or the preceding 60 or the preceding 30, then the future next change that we see is the Y? Or,
it's yes.
Or is it distribution?
Y is sort of the label. That's something that, because they observed it, right? They know that's what it was on average.
So they're saying this set of 30, 60, and 90 is labeled as a cluster or whatever.
It's labeled as that Y value. So going back here. So like if you saw this row of data, this sequence of price changes, you would then see on average this price after every interval. So, or not every, after all of them rather. So, and that's used as a label. So then later the algorithm learns these patterns and then it's able to provide those average price changes, and that's what you use in your trading strategy to be able to decide whether you're going to buy or sell. So yeah, so this function is just computing that equation, which is an estimate of average price change. And I'm not gonna go into the details of what it does. And then there's another function called distance, which it basically compares the two rows in here. So it can say how close they are. So, and that's what I was saying, like how close the patterns are. And this is, I believe, based on Euclidean, oh, this is L2 norm because Euclidean distance was too computationally expensive. Right, wait. No, I believe this was Euclidean because L2 was, okay, gotta remember this. Basically, it's a measure of distance that's faster to compute than Euclidean. Yeah, that's what it is. And they use that, as I said, to basically make the computation viable, because otherwise it would take them forever to come up with a result. Like basically it would take them longer to compute the prediction than to get a, like they would be outside of that 20 or 10-second interval basically, so. And then here what they do is they do this estimation basically based on Bayesian inference. They estimate the average price change using the training data, and then once they estimate that this average price changes, then they can train the model. It's basically a linear regression model. But the delta variables here, they're basically the averages estimated using Bayesian inference. So that's why it's called Bayesian regression. And then they do the same for the test data set. And at the end, they basically compare the test and the training, the predictions and the test data set. And they compute a mean squared error, and they're able to say how good their sort of model was based on that testing set. And I can actually run this and show what it produces. And obviously this is a very small training set. It's like only like 7 days or so of data. So it's not gonna be super good, but it's, to me, that seems like you could use something like this. Although I wouldn't bet my money on this. Yeah, that's why I don't trade, is because I'm not nearly as educated as you guys are. But right now, what it's doing, it's training. It's running the training algorithm, and so it's taking a little while for it to come up with the estimates for the coefficients in linear regression, and it so finally did that over here. Those are the coefficients, and then it computed MSE, mean squared error, which in my eyes is pretty good, but this is sort of the actual difference between, these are price changes. So the blue is what was predicted, and red, it was the actual price change. And so you could see, like in this time, and these are the 50 different times, rather. And so you see that in some places you get, like this prediction is way off, right? Because the price changed in this direction, but the prediction was here. But in other places, like over here, the predicted value kind of reflects the trend. And there are other places where you could see the same. And this is not using a lot of data, so that's the demo. And then I had a few more slides, basically talking about their trading strategy.
Do you know, is there a slide showing actual versus predicted with a lot of data?
No. And they, the paper also, they have a slide, a graphic like that, but they also had a few other parameters to this model. And so it doesn't quite show what I just showed. It shows how good the models work based on different parameters. So, don't remember how I got into the other mode last time. Oh, okay. Here, I'm just gonna use this view. I hope you guys can see. It's kind of small. Okay. Right. I think folks on the conference, they'll be able to recognize text, and folks in the room can see that. So their trading strategy that they devised, they only maintain a position of 1 at most. So you either have +1, 0, or -1. And then they use this model to predict price movement over the next 10-second interval. And if their prediction is greater than a threshold that they set, and the current Bitcoin position is less than 0, then they buy. If the prediction, prediction is less than the negative threshold and their position is positive, then they sell. Otherwise, they just don't do anything. And this is a sort of a quote from their paper. So they basically, it boils down to them not saying that they need more research to refine this model. And yes, go ahead.
Is this based on the price prediction and the probability of the likelihood of that price working out, being in the right direction, let's say? Or is it only doing on price?
My thing is it's doing it based on price, but within the model it's aware of sort of the probabilities. I don't know the math all that well, to be honest, but my understanding is internally the model is aware of probabilities. That's what the Bayesian regression part is.
The trading algorithm, that's not what I meant. Is that using probability, or was that just using price?
It's using average price. So kind of based on probability, since it's average.
Is it essentially thinking that a bigger change in price is a higher probability, and then play based on that? Is that a limit that you were talking about?
Yeah, I don't believe it's that. It's a very simple strategy, right? It's just looking at the price change, and if it's greater or less than the threshold, then they make a decision. Okay. Yeah.
Is the threshold fixed based on what they've done before? They compute the threshold. So
they try different thresholds, and they actually provide sort of a graph of how well the model does based on threshold.
Frankly, I don't think I've ever
and then they actually tried this, so they didn't just do it sort of in a vacuum, unlike me. They actually tried this between May 6th and June 24th, and then they were able to earn basically 3,362 yuans, and they're saying they got 89% return in 50 days with Sharpe's ratio 4.1. And they basically nearly doubled their investments in 60-day period. So, but that was back in 2014. And then they discussed sort of how this could be scaled, because their position is like at most 1. So then it's, if you want to get more out of this, you kind of have to find ways around it. So, and again, their conclusion was mostly that they need more research to be able to scale this strategy using this algorithm. So, and they're definitely not expecting like linear scale. So, any questions?
Okay, just so I understand here, would you have confidence in the results? In other words, a major problem in developing any sort of trading system was it curve fitted to the data. Did they do the experiment over and over again until they got great results? Because if they did, then you've got the chance that the possibility that they just ended up relying on chance to find parameters and so forth. Are there measures in here to prevent that from having happened?
Looking at, yeah,
it's tuned to this set of data. They're going to work on the data next month.
right, and so that's part of what I was saying. Because they're using Bayesian statistics, this can be changed in a way that it learns online, so to speak, as more data comes in. But the code that I showed you, actually, if you really want to try this out, there's a person who took this paper and they actually developed full-blown solution based on the paper. It's on GitHub. I can actually show you that repository. And they have a piece of software that pulls data from OKCoin and periodically basically retrains the model. So then you could use this as you go. So you don't have to use sort of the model that was trained in 2014. You could use the entirety of the data if you have enough compute resource. So
Yeah, I mean, the potential is there.
right.
But were they honest? Is their research valid?
Right.
In other words, have they validated it academically?
Good question. So looking at sort of their of the equations that they've come up with, and I'm not like really big into math, so I can't say if their derivations were right. As far as their validation method, it's basically, it was experimental, right? And you're right, it may be just due to chance that they were able to make this profit. I think really it remains to be seen whether this really works. If so, somebody has to apply and validate this more rigorously, I would say.
And can you explain what you did? Did you rerun their data, or did you get your own data from somewhere else?
So my professor gave me a data set that, as I said, was a different data set, much smaller, because for academic purposes, we didn't want to sit for 2 days and train this. So, but I did rerun the, what I just showed you, that graph of actual versus predicted, that was based on the data that I was given.
And do you believe that your results validate what their experiment?
No, I wouldn't say that. I mean, it's, even though like in data science, they call it validation set, right? If they take another data set and they run prediction on that and compare what the actual results were. But to me, real validation, you need to get like from actually applying this to a real life situation and seeing what you get, not just compare what you had with what you got from the algorithm. So.
This strategy that you're trading uses all the data, right? So it's using every single tick. Is that correct?
Not directly. It's because it's computing the intervals, right? So
But I'm
yeah.
saying that in order to aggregate to those particular intervals, you're using all of the available data.
You can, you don't have to. And that's where, yeah.
That's important because like in the equity markets, we know that there's that low volume debt. And so you really don't want to pay attention to price. Well, price is not as meaningful when the volume is very, very low.
I think actually what you're saying is similar to what they were describing. They were referencing a different paper called Latent Source Model, a paper where that concept was introduced. And I kind of skimmed through that paper, and the way I understood this is they were giving an example of Twitter. So let's say you have Twitter trends, right? Some topic, let's say birthday, and that topic will trend at certain times. Well, if some celebrity has a birthday, there is clear seasonality of that topic trending. And that, to me, that was a latent source. It's something that you don't see directly in data, right? The numbers, you just get the numbers of how many people are tweeting about that particular topic. But there is a sort of behind that data, there is an actual person who has a birthday. And so I think what you're describing is very similar. It's the prices themselves don't necessarily reflect that latent source, but there are patterns that you'll see sort of in the price variations that may reflect that latent source. And that's what this model is trying to do. It's trying to find those latent sources.
Can you identify, now here this is using Bayesian, a Bayesian model, which is supposed to be much, much better than a simple linear regression or something like that. Can you identify, can we see here that that is shown in some way? In other words, if they had done this whole experiment just with linear regression or whatever, do we know that it would have been better or worse? Can we see where that
improved? So, and that's another weakness of this paper actually is they don't do any comparison or like baseline models. So they just say, this is what we developed, and they don't give you an analysis. And being sort of in the professional world, I have seen data scientists do this kind of analysis where they take a model that they developed, but they also take, let's say, a baseline model like linear regression, and then they did their own neural network, and then they compare. They do an analysis of, this is how much better we got using our model versus linear regression. This paper doesn't have anything.
So this is really just saying this is how we would go about it to incorporate progressive, incremental, iterative improvement of a Bayesian model, but they really haven't shown that that was necessary or that it improved the results.
They didn't really show how they would be sort of online learning the model.
Yeah.
But they did
Show how they would do it, but they didn't show it was necessary or that it helped.
Yeah, kind of that way, I would say.
But it's, I mean, it's certainly other questions. Well,
patterns picked. You know, there's some patterns which were being used in these clusters. How were the patterns formed?
Right, so that's what I was saying. It's the clusters themselves are not formed, right? They already exist in the data. The algorithm just finds where those clusters are. So like basically it finds the coordinates of where those clusters are. Yeah.
What are they clusters made of? I mean, what do you have?
Yeah, so those patterns, let me go back to one of the slides here. So clusters are made of patterns like this, right? And they may not be like head and shoulders or triangle. They may be some totally random pattern. Oh, sorry. Yeah. Yes. So these are some of the examples of those points that the clusters consist of. And each point is basically a pattern like this. And not necessarily exactly like this, but basically you see a sort of price changes here.
So would these clusters be clustered in time, or are these clustered in what you might call shape space?
Good question. I think I'd have to I can answer your question probably offline. It will take me a little while to think through this, but I could definitely tell you exactly how. So that space, I could definitely identify the space where the clustering was done.
It's not time, it's something else.
It may be time, like I'm not gonna just try to guess right now. I'd have to look at it. And that's the thing that I was mentioning. The paper doesn't really document any of that, which makes reproducing it harder, but people have re-implemented their approach. So once you look at what they're doing, you can kind of understand what the space is.
It seems to say on the axes there, it says price movement on the vertical axis and time on the horizontal axis.
Yes.
So presumably it's saying like over 10 seconds, and you have this oscillation.
Right. These are the actual patterns, but then the patterns are points on this. If you look at this space, each pattern is sort of a point. So it's how they did the mapping. Like they don't say, but we can find out. So it would take a little bit of looking, but it's possible.
Well, I think it gives us a little idea of what's going on academically in some of these areas where we use sometimes very crude approaches. We see that people here have found use for an iterative development of conditional models using Bayesian statistics. I think I'd like to find out more about it at some point. Well, let's have a nice hand for Andrew. And we're going over to